We'll proceed in vector and commercial calculus. Vector and commercial calculus. Vector and energy calculus. Now, what we have seen till now is if there is an energy source, if there is an energy source, then energy source can be path independent and path dependent. If I have energy source, okay, if I have energy source like this, consider this is energy source. If this is energy source, then this energy source, the nature of energy source can be path dependent or path independent. Path independent means if anything, path independent means anything falls on this. If anything falls on this, then energy lost by this, if this item is falling on this energy source for any energy source, if I have any energy source will have force field. It will attract anything. This is what the physics says. If there is an energy source, it will attract anything. If there is an energy source, this is typically force field. Okay, what is the force field for Earth? The force field of Earth is mass into acceleration. The Earth acceleration is minus gm divided by r to the power 3 r vector minus g minus g is some constant minus g m mass of the Earth divided by mass of the Earth into r vector radial vector in polar coordinate system. If I take this, if I make this as center and rotate this radius, if I keep this as center and rotate this radius, this is polar coordinate system. The angle it is changing, that is theta, and this is radius. So if we talk in radial coordinate system, if this is energy source, then the gravitational force of this energy source is minus. Minus means toward itself. If this is energy source, minus means towards itself. This is minus. Outward itself is plus. Minus g is a constant. M is the mass of this r vector. Okay, towards its r vector, radial vector. Okay, divide by r to the power 3. That is the acceleration. If I multiply this with this mass minus g m r vector divided by r to the power 3 into this mass, that is the gravitational pull. Okay, whereas gravitational, if someone talks about the gravitational acceleration, or if I leave this mass, then more or less gravitational pull of the Earth is like minus gm r vector divided by r to the power 3. Now, question is arising: this earth is path dependent or path independent? Path dependent means if any item is moving in earth gravitational force, if item is moving from here to here, then if there is a velocity, means energy is involved. Where from energy is coming? This item does not have energy, but it is rapidly, it is moving like this. Okay, if it is moving like this, then there is some energy. Energy is coming from this earth. Okay, how much energy it involves when item moves from here and to the surface? How much energy it lost? That much energy is involved moving item from here to here. Path independence of energy source means the energy this earth is losing only dependent upon the begin point and end point and the force field. That's it. Not on the path. Either it takes a straight path, it takes a staircase path, it takes a parabolic path, does not matter. What is the begin point and end point? That only matters in the energy calculation. Then it is called path independent. Otherwise, if item moves from this point to this point in a straight line or in a circular line, in an elliptical line, whatever, everywhere energy lost by this energy source is different, then this energy source is path dependent. If it is path dependent, energy source is reflected through the force field. How I know energy source of this earth? I cannot go inside the earth and see the energy source. whatever the force field Earth is showing, through that force field only I can adjudge that what is the nature of the Earth energy. So in that sense, now people have started talking about path independence. Path independence means the energy is dependent upon only begin point and end point. If I make something revolve in a circular way, in a closed loop, then energy involved is zero because begin point and end point is same. Okay, then if begin point and end point is same and energy involved is zero, then it is path independent. But if there is energy involved from begin point to end point, then it is path dependent. How much it is path dependent? Calculate the energy involved from begin point and back to begin point. How much energy involved? Divide it by the area it is making. That is called circulation density, and that much is the energy involved. This is same as curling factor. This is called circulation density. Circulation density means how much it is path dependent. If I have an energy source, how much it is path dependent. How much it is path dependent, it adjudged by the circulation density. What is the circulation density? Is take a item in the energy in the force field of this energy source, take the item and from begin point bring it back to the same point. Through the it will happen in the energy force vector of this energy source. If it is moving from one point and coming back to the same point, how much energy involved? Divide it by the area. Whatever is the energy involved, that is called circulation density, and that gives the nature of this path dependence of this energy source. Energy involved in a closed loop divided by the area found by the closed loop is called circulation density, and that is the measurement of how much it is path dependent. Or calculate the curl factor. Curl factor means consider one item is moving toward Earth or any energy source, and this is the item. If this item is rotating and going toward the energy source, it looks like this has some curl factor, rotation factor. More rotation factor is there, more it is path dependent. If it is path independent, then there is no rotation factor. It will go straight like that, like Earth is path independent. If I drop this, it will go straight on the Earth. If I drop this, it will go straight on. It will not rotate like this. But more it rotates while going to the energy source, more it is path dependent. This is the another characteristic people saw. One characteristic is path dependence means moving from one point coming back to the same point. There is energy involved. Divided by the area, that will tell you how much it is path dependent. Or same thing is if you calculate the rotating tendency of this energy source. Rotating tendency of this energy source is rotation tendency of the energy source is, if this is the force field, it has two components, F1 and F2. This is x-axis, this is y-axis. Okay, this is F1. If F1 is going along y-axis and it is changing, then it will place here F1 is different, here F1 is different. It will place a torque like this. Similarly, if F2 is different, then it will place a torque like this. If net these two torque, one is dF1 by dy, one is dF2 by dx. If these two torque are different, then it will have a torque. If they are same, they nullify each other. One will place torque like this, and other will place torque like this. They will nullify each other. Then again, there won't be any torque. Means if dF2 by dx, F2 means this vector. If it is not dF2 by dx means it is changing if I go along x-axis. Df2 by dx minus df1 by dy. If this is changing when we go along y-axis, df2 by dx minus df1 by dy is 0, then it is path independent. Otherwise, how much it is, that is the nature of the energy. So that much it is path dependent. That much it is path dependent. df2 by dx minus df1 by dy. That much it is. That is also called curling factor, and it is same as circulation density. That we have proved it. Okay, now example generally I give that a leaf falls from tree. If you watch in the kind of season, autumn season, when there won't be any leaf on the tree. And now it will start. After 1 month, the autumn season will start after winter. And then the leaf, when it comes out of the tree, it will start rotating very heavily, very high angular speed. Tree, when tree leaves the tree, it will rotate, where rotate, not shackle, it will rotate, and it will go on the earth. If you take the same leaf and place it on the tree and drop it, it won't rotate. Means earth gravitational pull is path independent, it won't create any curling factor. But tree, when the leaf leave the tree push some energy, curling energy there, and it rotates. So tree has curling factor, not the earth. Anyway, now question is arising, how much curling factor earth has? Earth has curling factor. I know, no, does not have curling factor. Prove it. I know earth has. I saw a leaf that is falling from the tree in the autumn season. It rotates and then goes to the earth. Earth has curling factor. I have seen from my eye, naked eye. In it, you see, just stand uh, uh, down to the tree, okay, and then just watch carefully. Leaf falling from the tree, they will rotate. Okay, this proves that Earth has curling factor. Someone would think. Now prove that Earth has curling factor or not. That is the question. Okay, tell me what is the gravitational force of the Earth? Gravitational force of the Earth is minus gm. Minus means in radial coordinate system. It is in polar coordinate system. It is toward the Earth. It is toward the Earth. Okay, if that is the case, then Earth gravitational pull is minus gm, minus gm, okay, divided by r to the power 3 and then multiplied by r vector. Minus g is a constant, m is mass of the earth, r vector means toward the center of the earth, divided by r to the power 3, that is, and if you multiply by small m, then it will become a complete force. I leave it a small m. Small m is the item that is moving toward the earth. I leave the small m, then still the gravitational force is something like this, minus gm r vector divided by r to the power 3. Prove it that it has no curl factor. Okay, then r, if I change it to Cartesian coordinate system, then r vector will become xi plus yj plus zk. Okay, if this is the center and this is x-axis, this is y-axis, this is z-axis, and this is polar coordinate system. If I take any point r, then this point can be substituted as x comma y comma z. Okay, that point. If you draw a line from the center, that position vector will be xi plus yj plus zk. So the Earth gravitational pull, I can say minus gm. Minus gm is constant, just leave it. Minus, leave the minus also. Okay, r vector divided by r to the power 3. R vector is xi plus yj plus zk divided by r to the power 3. Then it will become x square plus y square plus z square to the power 3 by 2. Okay, so xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. This is Earth gravitational pull. Prove it, it is path independent. If it is path independent or dependent, we will see the curling factor. If we see the curling, how to calculate curl of this? Okay, now if you see carefully, then this equation has two parts. One is algebraic part, that is 1 by x square plus y square plus z square to the power 3 by 2. One is vector part, xi plus yj plus zk. What is the curl factor of a situation where I have considered there is algebraic equation called phi, and a vector called f, phi into f. What is curl of phi into f? Okay, now phi is phi, f is f1i plus f2j plus f3k. Okay, that is the, now if I multiply this, then it becomes phi f1i plus phi f2j plus phi f3k. This is what curl we are trying to calculate. Now let's leave the k factor. Now it will be simple. Now we have phi f1 plus phi f2. What is curl of any vector? Curl of any vector is a determinant of a matrix where we have first row as I, j and k. Second row is d by dx, dy dy and d by dz, or if you take three dimensional. Third row is f1, f2, f3. Now if I take k side, calculate the determinant in the third column, first row, that is k. I, j, k, d by dx, d by dy, d by dz, and then f1, f2, f3. Third column and first row, if you cut, what will be the determinant? Then it will be df2 by dx minus df1 by dy in k vector. This is the curling factor for two dimensional. Okay, now df2, what is f2 here? Phi f2. D of phi f2 by dx minus d of phi f1 by dy. D of phi f2. Okay, if I go with the phi f2, then what is differentiation of phi f2? Keep phi outside, then df2 by dx, plus keep f2 outside, then d phi by dx. Make sense? Phi df2 by dx plus f2 d phi by dx minus same thing there. Phi 1 df1 by dy plus f plus f1 d phi by dy. If you take it, everything you settle down, then it becomes phi and df2 by dx minus df1 by dy. Means phi into curl of f. Phi into curl of f. Okay. And what is the next term? Next term is phi. Next term is f1. Next term is f1 minus, and then in bracket. Next term is minus, if you, okay. Next term, if you, okay, I'm sorry. Next term is f1 d phi by dx. f1 d phi by dx, sorry, f2 d phi by dx minus f1 d phi by dy. Okay, it is same as f1 f2 d phi by dx. It is same as, it is kind of phi d, I'm sorry, the gradient of phi, d phi by dx, d phi by dy, gradient of phi cross product with the force vector. Gradient of phi is d phi by dx I plus d phi by dy j, cross product with the force vector f1i plus f2j. If someone calculate this, then df d I doesn't make any sense, I and j, df2 by df2 by dx k, and j and I minus k, df1 by dy minus k. Same thing comes here. So the net, if I'm trying to calculate the curl of algebraic equation phi into the force vector f, is nothing but the kind of uh, phi, algebraic phi into curl of f plus 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 gradient of phi cross product with the force vector. Okay, let's proceed for the earth also. We are not running away. Let's calculate for the earth force vector. Now it is coming as phi into curl of f. Phi is 1 by x square plus y square plus z square to the power 3 by 2 into curl of f. Now curl of f is xi plus yj plus zk. xi plus yj plus zk. Now curl of xi plus yj plus zk, first it will be I factor, j factor and k factor. If you see I factor, then it will become df3 by dy minus df2 by dz, df3 by dy minus df2 by dz, df3, f3 is y, dy by dz 0. df2 by df3 by dy 0, df2 by df2 by dz, f2 is y by dz 0. Okay, then j term, then k term, all will become 0. Okay, so the curl of phi into f is phi into curl of f. Curl of f is 0. So this is 0. Gone. Okay, next term is gradient of phi cross product with the force vector. Force vector is xi plus yj plus zk. Cross product gradient of phi. Okay, gradient of phi. So how much it will be gradient of phi? Now if someone calculate this gradient of phi and cross of force vector, then calculating the cross product means I j k. Now I have to take in matrix I j k, d by dx, d by dy, and d by dz, f1, f2, f3. Okay, now same thing will come d. Okay, I'm sorry. First row will be ijk. Second is d phi by dx, d phi by dy, d phi by dz. Third will be f1, f2, f3, f1, f2, f3. Now, if someone proceed like this, then take I term, first column and first row I term, then it will become d phi. It will become d phi by dy into f3, d phi by dy into f3 minus d phi by dz into f2. What is d phi by d phi by dy? Phi is phi is 1 by x square plus y square plus z square by into 3 power 3 by 2, d phi by dy into z into d phi by dy. If I calculate it, it will become minus 3 by 2 into 2x, minus 3 by 2 into 2x divided by x square plus y square plus z square to the power 5 by 2. Okay, 2 gone, x into y, minus 3y into z, minus 3y into z divided by x square plus y square plus z square to the power 5 by 2. Now minus d phi by dz into f2. F2 is y into d phi by dz. Phi is 1 by x square plus y square plus z square and then power 3 by 2. If we do go with same thing, one thing that someone must understand this, okay, minus is there at the beginning only and we will get minus again, minus minus plus, and y into 3 by 2 into 2, it will become 3z. So it will become here minus minus 3z into y by something plus plus 3 into y into z by something. It will become 0. Ith factor is 0. Similarly, j factor will become 0. Similarly, k factor will become 0. K factor will be d phi by dx, d phi by dx into f2, very famous, minus d phi by dy into f1. So f2 is y into d phi by dx, y into d phi by dx. d phi by dx will come as minus 3x, and here y minus 3 into xy divided by whatever it is, plus d phi by dy, d phi by dy into f1. d phi by dy is minus 3y by something into x. Now it will come to same situation, minus 3xy by something plus 3xy by something. If that is the case, it becomes 0 again. Okay, so calculating the curl of Earth gravitational pull is 0. There is no curl from the Earth gravitational pull. Means if you drop any item in the vicinity of the Earth, it will not rotate. It will fall. It will not rotate. It will fall straight forward. If tree leaf is falling from the tree and it is rotating, curling at a very high speed, and if you take the leaf again to the tree and drop it, it will not curl. Means neither air has curling tendency nor the earth has curling tendency. Means the tree will leave any leaf of the tree, leave the tree. At that point, tree inserts some energy there when while the departing it. and that is the curling force or energy, and that leads it to rotate. Otherwise, Earth is curl free. I believe it's all right. Means this is how we prove that Earth is curl free. Someone can, or if someone really want, he can try other way to prove it is path dependent or independent. What is required here is calculate the loop energy. In a loop, how much energy is flowing? Make a loop point A and back to the point A, and make something move in Earth gravitational pull back to the point A, and then calculate what is the energy computation in a circular loop. Okay, what is the energy computation in the circular loop, and then divide it by the area. So that will be circulation density. That also talks about the kind of energy computation. Can someone try? What is the energy computation in circular loop? What is energy computation? Energy computation is force vector dot d of position vector, d of position vector, or force vector dot displacement vector. That is energy computation. What is the force vector and displacement vector? What is the force vector and displacement vector? Consider this is Earth. This is Earth, and something is rotating in a circular fashion around the Earth. Makes sense? This is also a case. Now, Earth gravitational force is in R direction. An item is moving in a circular fashion around the Earth. If I take this, okay, if this is Earth, if this is Earth, then this is the path of any item is moving around the Earth. If this is Earth, then this is the any item that is moving around the Earth. If item is moving around the Earth, okay, then item has displacement. Displacement is a vector that is exactly tangent along the path of the movement. If this is the movement path, okay, if this is the movement path, then at any moment the movement vector will be exactly tangent at that point. Okay, tangent at that point. Now, this is radial, that is the Earth gravitational pull, that is xi plus yj plus zk, or r vector. R vector means radial vector. Every moment radial vector. Whereas the circle movement is tangent. Now, this radial vector and tangent vector are perpendicular to each other. Okay, how someone can prove it? They are perpendicular to each other. Now, if I take radial vector, if I take any point x comma y here, then this radial vector will be xi plus yj, xi plus yj. Now, if I talk in a polar coordinate system, it will be r cos theta I plus r sine theta j, r cos theta I plus r sine theta j. That is the kind of radial vector. Okay, I believe this is too much we are doing. So idea is that how we can show, how we can show that tangent vector. Okay, if I believe you have to watch one video. There we have talked that tangent vector is perpendicular to the any vector that we differentiate. If there is any vector here, okay, if I, okay, what is the tangent vector? Tangent vector, if I differentiate at any point here, dy by dx, if I differentiate a point here, this is x-axis, this is y-axis. If I take any point x comma y, at that point, if I differentiate this algebraic equation, then dy by dx will be the slope of the line that it forms like this. If equation of the line is y equal to mx, where m is dy by dx, then that line is nothing but that is the tangent line. That we know. Dy by dx is tangent at that point. I'm not talking about circle. I'm talking about any curve. If I take any curve, and I have curve equation. If I calculate the dy by dx of this curve at any point, then the dy by dx, if I make a line that y equal to dy by dx into x, now I don't want to go even depth of that. If I calculate y equal to dy by dx into x, a equation of a line, that line will be tangent at that point exactly. Okay, if that is the case,